What's going on, everybody? So before we kick this off, we wanted to give you guys a shout out. We didn't really think that this many people would come to our talk, so super pumped that you guys showed up. Hopefully it doesn't suck, but regardless, thanks for coming out. We really appreciate it. So to kick this off, cool. So my name is Stroud. I'm an RIT Computing Security Master's student, Sparsa alumni, CCDC alumni, and I would describe myself as a startup enthusiast, to whatever that means to you.
So I'm Bryan, and then the same thing, basically, and I have cool shoes that I'm rocking today,
So to go through a little bit of the agenda that we had set up for today, we're going to talk about where the background for our talk came from, some previous work that's been done, what the motivation was that led us to this talk, and then we're going to dive into two DevOps tools, Ansible and SaltStack, and talk about how their functionality can help you scale and automate your red operations. But first...
so trigger warning. We have a lot of buzzwords in our talk. Hope you guys get super pumped. If you're not, then, I guess you can leave if you want. Our talk, hopefully will be pretty cool. But just DevOps in general, it comes with a lot of buzzwords. So just a heads up. And for anybody who's about the whole, I'm going to take a drink after every buzzword, about 4 slides from now, you're probably going to be on the floor. So I wouldn't recommend doing that.
So we keep saying this word DevOps, and this big old DevOps hype train that
hype?
a bunch of people keep shouting out. But we're going to establish a ground basis of what we mean when we say it. So really, at the end of the day, it's whatever tool allows you to automate something and be reliable against a variety of environments. So whether that's spinning up several different nodes in AWS, to using the same kind of infrastructure but putting it over in a different cloud provider, there's these tools that allow you to replicate reliably, deploy code, push out tests just continuously. So some of you guys might think of Jenkins, Ansible, and SaltStack. Obviously, we're going to talk about today. We don't mean it in the philosophical way where it's it's a cultural thing and it's how many Scrum meetings you do. So just to kind of have a basis, it's really just making sure that whatever you're doing is reliable across different infrastructures. So, going on to the motivation. Bryan and I both do some malware analysis as side projects and hobbies. So we always really like when we see malware that's using the inherent environment and sysadmin tools to move laterally through a network. So it's not doing anything super crazy, but it's using tools that are already there, something that's already there for the advantage. Why bring the guns into the place when you can just use their guns, right? That kind of idea.
Has anybody seen Chris Gates and Ken Johnson's talk called DevOps? All right, so a couple people. For those of you who have not, it's actually a pretty cool talk. They talk about how people mess up a lot of things when doing DevOps stuff. So, for example, pushing API keys to GitHub or leaving their .git directory publicly accessible for their website so that you could just pull it down. So we thought that it would be cool to also build on another DevOps talk based off of that kind of stuff. So that was another motivation for our talk.
Yeah. And also, competitions. How many CTF players do I have in the house? Nice. How many CCDC alumni or attack defend people just in general for these competitions? Yeah, nice. So if you're not familiar with CCDC, it stands for Collegiate Cyber Defense Competition, and it's basically when a bunch of college students go and sit in a room, and there's a group of professional red teamers, and they make us have a super bad time to an inherently vulnerable environment. So the whole idea behind some of these attack defense CTFs, though, if you're not familiar with them, is that you'll have an infrastructure, it'll be vulnerable in some way, shape, or form, whether it's just super simple things like default creds, exploiting a web app, or some kind of custom network surface that you have to actually create an exploit for and then take advantage of the machine. Once you get onto the machine, you need to find some kind of token and replace it with your flag so that the corresponding scoring engine can give you points. So, at the end of the day, the only thing that really matters about this is speed. But to continue some of the things that we talked about, all of this living off the land mentality is going to become really interesting with DevOps tools, because these are already inherently trusted tools within an environment. They're not going to flag AV, they're not going to flag your NIDs or other network controls that you have, and they're allowing for remote code execution. So if I said something to the effect of, you have something on your box that calls back to me every 10 to 15 minutes and then runs any command I give it. This sounds kind of like a botnet, right? I could be talking about a DevOps tool. They're really analogous for the same thing. And we'll dive into that in a second. But to kind of talk about the objective here is that we want to automate these attack defense CTFs to an extent. We know that there's going to be an infrastructure that's inherently vulnerable, right? We're always going to have some kind of default creds that we're going to be able to get onto some boxes with, and we want to be able to do this fast. Some of the ways that people are trying to automate this now, everyone that competes in these usually have some kind of subset of Python scripts or shell scripts that allow them to automate some of the simple things that they're trying to do. But these don't really scale out well, especially when you continuously add more machines to an environment or you go from one competition to another. So that's where this whole DevOps mentality of run once but run everywhere and accomplish the same goals can really be advantageous to these competitions.
Just one quick note about that is that we're talking specifically on going back to red teaming and competitions as opposed to from a pen testing perspective. So when you're pen testing, you might not get default creds to stuff. Probably you most likely won't. So that's where we're coming from with that. So.
But for the pen test people in the house, didn't forget about you. So if you're trying to automate, say, like a MySQL dump across the entire network, or it's MySQL, but then they have NoSQL databases, or they have kind of a plethora, a mixed match of these technologies, you can use these kinds of DevOps tools to chain things together. So when you hit a machine that has Redis or MongoDB or MySQL or Postgres, whatever the case may be, you can run these series of tasks depending on what they have, so you can kind of on the fly make your own tools to get some of the low-hanging fruit. So while our talk is mainly related to just automating these red team attack CTFs, definitely wanted to make sure you guys are still thinking in the realm of how this could be used for pen test engagements. So with that, we're going to dive into Ansible. So out of curiosity, has anyone used Ansible here? Nice, cool, got some hands. So Ansible's really attractive for a number of reasons. First off, it's completely agentless. So it operates completely over SSH to the remote node. So if you have SSH access to a remote host, you can automate Ansible to run something called a playbook, which we'll talk about in a second, on said host. The best practices mechanism relies on you having SSH keys on the remote host, but there's nothing stopping you from just having passwords that you try against the host. So if you put this in a for loop, you can now run these Ansible commands basically as a brute force mechanism to then launch other evil things, which we're going to dive into. Additionally, Red Hat just bought Ansible in 2014, so this is going to become more of a prevalent tool that I believe you'll be seeing out in industry. It uses, like I said before, it uses completely SSH for communication, and it can actually be installed with pip, the Python package manager. So if you just do pip install Ansible, you now have Ansible on your machine. So a simple Ansible architecture kind of looks like this. You have your one Ansible master node, so to speak, and you have these things called playbooks that I keep alluding to. So the idea here is to have repeatable task execution to accomplish the same goal regardless of what your infrastructure is. If it's a developer machine, not a problem. Production servers or entire data centers, as long as you have some kind of access via SSH to these machines, you can execute Ansible playbooks. So going into targeting based on what your needs are. Ansible inventory is how you go ahead and specify the hosts that you're looking for in an infrastructure. So off to the left here, we see a format where you have just the brackets. You specify what kind of category these hosts are. So you could say database servers, web servers, whatever the case may be. And then you can just list underneath them IP addresses or fully qualified domain names. Additionally, you can pass in Ansible port, which would be a different SSH port for that machine, passwords, and usernames. So, like I said before, if you don't have keys on the remote host, it's not the end of the world. You can still access them just by doing a command line argument to provide the password. So this kind of allows you to break down, the database servers, I have these scripts or these sets of tasks I need to do to accomplish, again, on those machines. So this, like I said before, can just be changing a banner or dumping the database entirely. So finally to the thing that I keep talking about. Ansible playbooks can be described as executable documentation. They're in a pretty easy to read YAML format. As of the time of this presentation, they have 200 plus core modules, which allow you to do a variety of tasks against an environment. And it's just, they execute sequentially, so you list what you're trying to do, and it'll just go through and then execute it in that order. You can also just specify, only run the MySQL commands against these hosts, or kind of chop it up however you'd like it to be. These playbooks can be platform independent. However, what is said in theory doesn't necessarily translate to practice. There are some caveats that you need to be aware of, so definitely test this before you just kind of go out and think that everything will work super fine. So as I said before, it's in a YAML format, and you can specify the options of what you're running against with tags. So let's see what one of these playbooks looks like. So this is the typical structure. It's a pretty small playbook, and at the top here you see you specify the hosts. So www, going back to the Ansible inventory file, you specify the remote user that you want to run as, and then you can specify some variables for what you're trying to accomplish later on with these tasks. So up here we see we have a GitHub repo, and we also have a pastebin document that we can download code from and then run it if we so choose, and a directory where we want to store things on the remote host. So we see going through these tasks, you see this naming tag. This name tag is more of a descriptor, which will actually fire back to you when you run these if the status was complete and what you ran. So the package is going to install Git. Git URL, pretty intuitive, right? You know it's going to go download something, says where to save it and what permissions to save it as. You can schedule tasks with cron, et cetera, et cetera. So everything that you probably have some kind of shell scripts for that you've used in these attack defense scenarios, you can take and port to Ansible fairly easily, or build up pretty robust tasks with Ansible. So when you run these guys, the really nice thing about Ansible is that you get visible feedback almost immediately. So in these attack defense CTFs, from a red team's point of view, it's not just about, I got in the box, got a root shell, I won. You have to usually keep track of what you're trying to do and when you did it. So a lot of tools don't necessarily have a reporting mechanism, and it can kind of be a pain to sit there and be like, what did I do like an hour ago to team 6, right? Well, if you divvy up your inventory file in a way that you specify what team corresponds to what IP address or what domain names, Ansible can just immediately provide that feedback along with what time that these executed on. So it's kind of a nice way to keep track of when you're doing things. So as we see, running this against the remote host, this is what it looked like from the remote host aspect. This downloaded the pastebin script and echoed who am I to wall, see that I'm root. So it's pretty straightforward in terms of how you can execute these modules. Speaking of modules, these are what goes in the Ansible tasks. And if you're already thinking of like, hey, I have some super secret sauce things that Ansible might not already have tasks and for, you can actually make them yourself. And all they are simple Python scripts. So if you already have Python scripts, incorporating these into Ansible is going to be super easy. And that's another attractive feature of this, is that it is all in Python. So this is right from the Ansible documentation, but it's really just any task that you're trying to accomplish on a system and get immediate feedback for. So these usually aren't very large functions. It's usually really small things, like changing some setting in a config file, adding users, dropping SSH keys, whatever the case may be. This is typically what you see with Ansible modules, and they kind of just allow you to perform some basic tasks. That being said, nothing stopping you from running some kind of Python crypto locker and then running this against remote machines and making the blue teams have a super bad time. So now that we've gone through all of that, and we kind of have a nice warm fuzzy feeling of what Ansible is and some of the capabilities of it, we're going to talk a little bit about some of the offensive operations, so to speak, that you can do in these kinds of environments. So once again, they are geared towards the competitions that college students compete in. So pen testers, this is a little bit outside of your normal day-to-day operations. So how many people here have read Black Hat Python? Awesome. So you guys are familiar with the GitHub botnet there, where you just immediately establish some kind of agent on the hosts, and then you have it pull from GitHub and execute some kind of tasks. Well, using the cron module corresponding with the Git module, you can set up to schedule the pull from a Git repo. So this seems pretty easy because you can't necessarily guarantee how long you can be on a box when you walk into these infrastructures. You don't know what other teams are going to do, and you need to maximize the amount of surface that you get on, or excuse me, the surface area of boxes that you go to, rather than staying on one box and securing it, you might lose a foothold in another machine. So you have to move fast, right? So this allows you to immediately schedule a task so that whatever you put in this repo will execute on the host machine. So that way you don't need to worry about you actually maintaining access through SSH or anything like that. You can just update that repo from your machine. It'll pull down and execute whatever that case may be. So if you lose SSH access, not a problem. That cron job still executes, and you're still going to be able to spawn another shell and still have access to the machine that way. So we have a nice Ansible playbook that actually accomplishes this on a GitHub repo that we're like sharing some of these tasks at the end of the talk. So just like before, when you run this, that green gives you that immediate feedback saying that yes, this executed okay. Where you see yellow, that's where things change. So that's where a file was updated, a file was deleted, whatever the case may be. And anytime you run any bash command, it'll always pronounce change because it's going to redirect to a standard out by default, unless you specify it to go to a file or something like that. So once again, you can immediately know if these tasks are executing successfully against your environment or someone beat you to it. So for the blue teams, so going to like CCDC, because I know that Ansible was used successfully at the NE CCDC region this year. Ansible by default does not log on the master node, but on all the end nodes that it's logging into, it does leave some nice little traces of the tasks that it's executing as. So we see that we have it highlighted red, Ansible-get URL. We saw this in a previous slide. This was obviously downloading the pastebin script to be ran later. Also at cron tab, we see in this really terrible to read dark blue up here, we have Ansible and then scoring engine. That being said, this is an open source tool. There's nothing stopping you from changing these values, but just so you know, by the default, this is what's going to be left on a machine when you run said tasks. So now we've talked about like super basic way to get on the machine, make sure that you can come back to that machine in a little bit while you're trying to move throughout the network. But really, at the end of the day, you need to be really, really fast, right? You can't risk other teams getting on these boxes before you and just like firewalling you off. So Ansible has a lot of ways that you can optimize it. We're going to talk about a few of them here. So some of these optimization facts allow you to basically skip a lot of core things that Ansible would do that would be advantageous to system administrators, but not so much advantageous when you're just trying to move fast and execute things across the machine in a competitive environment. So SSH pipelining basically limits the numbers of SSH connections, but will maximize the commands executed over them, so it cuts down on overhead of how many connections to a given machine. Forks, obviously more threads, depending on the tasks that you're trying to execute and what your machine can handle. You can have multiple SSH connections to multiple machines. By default, it's only 5, but you can scale that up to whatever your machine can support. But the most tedious one is this gathering facts. So when you run in command against the remote host, it does this thing where it basically profiles the system and understands what certain variables are. So what is the underlying packaging system? What is the underlying kernel, this, that, and the other thing, and that kind of gets passed into some of the tasks depending on the variables and the tasks that you're trying to execute. That being said, some of these take a very long time to accomplish, and if you just need to know the underlying packaging system, if you're trying to do the platform independence way, you don't need to do this like long, tedious task, right? So you can go ahead and disable this or fine-tune it so that way you don't spend all this of the time on a machine. So to give you kind of an idea of how long this took, with a simple way to figure out the uptime of the machines against 2 machines, this happened in about 46 seconds. So that seems super long to me, just to get uptime on some remote machines to run that against, right? 46 seconds to get uptime of 2 machines. So this is before the optimization. So after we went through and we said, I don't really care about this gathering facts, I want as many forks as possible, and I don't really care about, or I want SSH pipelining, we're able to get it down to just point a little bit under a second. So that was reliable too. We tested this 3 times. So once again, this is definitely curtailed more towards the CTF side of things because you do lose some of the inherent functionality that sysadmins would use this tool for. But now we're going to talk a little bit about DevOps with DevOps, and that's where things get super buzzwordy. So apologize in advance, everybody. But Bryan's about to take over and talk about Salt Stack and why this is advantageous. But we were able to bootstrap Salt on 3 machines from scratch, point it to our master, Salt Master, which Bryan will talk about in a second, in just under 2 minutes and 25 seconds. So this was pretty fast overall, and we'll talk about why this is important in a second.
I think there are a few slides down the road where I actually listed the bootstrapping commands. So I'll show you those guys in a bit, but there's one command that you can run that only uses Python to pull down and the URL lib2, which is a default Python module. You don't actually need to pip install anything additional. So what it does is it pulls down the bootstrapping script from Salt's website, and it will execute it so that it will install the Salt minion on the nodes to point back to your master, and you can push out different tasks to it using Salt. So yeah, we can talk about that in a bit.
But that still means that there is still support for those old dirty bash tricks that everyone has, right? So if you compete in this competition, you start collecting a series of scripts that you've used from A to B, and you collect them just in case they can be useful again. So it's super easy to port these to Ansible and use them in a variety of ways. Once again, we have these kinds of stuff up on the GitHub, so that way we can show you guys a skeleton key of how you might be able to use these in these attack-defend environments.
So Ansible is pretty cool, but I'm a big fan of using Salt for this kind of stuff. And there are a couple of reasons for that. Mostly it's architecture-wise, which I'll get into in a bit. But a little bit of a background is that, as I mentioned, it's agent-based. So how it works is the agents on the Salt minions will check in with the master to see if there are any tasks that are assigned for it, and if there are, then it will execute them. And it checks in on a fairly regular basis, so every few seconds by default. So another interesting thing is that the master minions run as root by default. So during competition events, it's useful having root on the box with Salt minions because you're root on the box. So by default, the master runs as root, but if you're actually using this in an enterprise, you can change that, and you can also configure it so that it uses some sort of external authentication like LDAP or Active Directory integration. And so you can actually limit the commands that different people in your organization are able to actually execute and what hosts they can do that. But from a competition perspective, that's not really too necessary. By default, Salt listens on port 4505 and 4506. And I read that in their documentation, by default, Salt minions try to connect to a DNS to the host Salt. So when I first read that, I was like, oh, you could probably take advantage of that somehow, if you're able. But I mean, if you're able to get on somebody's DNS server, they're probably going to have a worse problem than that. So a couple of the terminology that Salt uses is that it uses what's called a Salt grain. And so what those allow you to do is narrow down your target set. So you can say, I want all of the Ubuntu boxes, or everything that is Debian-based, or anything running the Linux kernel, or all Windows machines, things like that. And then you can give them tasks to execute. So that right there is an example of running Whoami on everything that's Ubuntu. So there are Salt modules, 2 different kinds. There are execution modules and state modules. So the execution modules are just a bunch of built-in modules that you can add to states. So for example, the command module is a built-in execution module. And with the state modules, you can write them, and they're files that basically can configure any of the hosts that are checking in however you want them to. So we'll get into a couple of different ways that you can use those for. And so the state modules are similar to Ansible playbooks. That's basically the same thing. And they're also a YAML format, so the syntax is very similar as well. And then there are Salt formulas, which are pre-written Salt states that are pushed up to the official Salt formula repo that people write, so that if you want to enable RDP on Windows boxes, somebody went through all the time and actually figured out how to use those. So you can actually take those and build those into the Salt states that you're writing. And then there are what's called Salt pillars, which are also just Salt state files, like the YAML format, that are just a bunch of variables. So if you have a Salt state that adds a bunch of users to the machines, what you can do is in the pillar files, you can say, like, here, this is the username I want, this is the name, this is the UID, this is the GID, this is all the GCOS information that you want to add for these users. So it's really, like, fine-tunable to be able to take advantage of salt pillars. And then, so why use salt for, like, from a competition aspect, why I really like it is that, as we noted before, it uses a polling mechanism, so the minions check into the hosts. There's nothing stopping you from running the master on ports 80 and 443, which will most likely be allowed outbound. So once people figure out how to write firewall rules, they'll usually block ingress stuff in. There's like not really any reason that people need external SSH access to their hosts, so they'll probably block you off that way, but chances are that they're still going to allow 80 and 443 out because everybody allows web out. And people really suck at writing egress filters in general anyway, so yeah, that's another cool reason why I like it. So as I mentioned before, there's bootstrapping, so you can install, if you just upload the Salt Minion executable to a Windows box, you can install it with one command and it will do everything in the background for you. There's no additional configuration that you need to do. You just say, hey, I want to point this at this master server, and it will take care of everything else. And then that's the command that will download the bootstrap script for like Nix boxes, and it will configure it and then point back to the master. So what would you do as a red teamer for an event? Any ideas? No idea.
Zero bootstrapping.
What?
You need zero bootstrapping.
All right.
Yep.
All right. Good call. All right. Any other ideas?
Yeah.
Add users.
Add users. Good idea. Any other ideas?
Black keys.
Nice.
Good call. So what we did was we came up with a proof of concept with a few of these things. So dropping SSH keys, adding users, ensuring remote access is enabled, like SSH and RDP, and like installing stuff basically. So if you're dropping SUID binaries, if there's no GCC on the box, you're probably going to have a bad time compiling that. So you're going to want to install GCC in order to be able to do that. Next. So here's an example of what's called the top file. So every time minions check in, they look for this file. And inside the top file is where you list all of the other state modules that you want the minions to execute. So these are just a few modules that I wrote, with the exception of the Nginx one because that was a salt formula that I was using. That will, like, the wildcard there, the star, will say on every host that checks in, I want you to install, like, these packages, add these users, and make sure these services are enabled, and drop some SUID binaries. So this is before I actually had Windows hosts in the environment, then I had to add that after, and I guess I just forgot to change that, because you're probably going to have a bad time, like, dropping SUID binaries on Windows, but, so yeah, next. So here's an example, just what I did for installing GCC. So you can see at the top there, you're using grains to actually limit what hosts that are checking in. So this is saying that every Linux box install GCC on. And then you can see down here, install Vim on Debian-based OSs. And it's called Vim Enhanced on like Red Hat-based ones, because enhance. I don't know, whatever. So, yeah, next slide. So here's how you would drop SUID binaries. So on your Salt master server, you would have a source file that every time the minions check in, they will make sure that they have this file on the box, and they'll store it in temp.src.c. And then there's the command to download, to compile and then change the owner and file permissions for the executables themselves so that it actually is an SUID binary. And you can write a for loop that says, I want to install all of these, compile all of these and put these at these locations. So for each file, you can give it like a full path to where you want to drop them. So to make sure that SSH is running, on Debian and Red Hat based OSs, this is literally all you have to do is say SSH and SSHD, and then if it's not running, it will make sure that it's running. It will restart it for you. So one thing that you're going to want to do is cover your tracks, and that's actually really easy to do. So you can just configure a log level to be quiet in the salt minion configuration file. And if you don't, by default, it runs as warning. And so that doesn't actually list any commands that run successfully. It will list stuff that you do not run correctly. So what I did was I ran who am I, but it spells who am I wrong. And you can see at the bottom there, it says who am I not found for anybody that's sitting in the way back. Sorry, the font was really small, but this was a really small picture.
So, going back to triggering everyone. So the agile red team workflow. So how you move within an environment and how you operate as a red team. So typically, the whole idea behind being successful in these competitions was you'd first get onto the box, you'd persist somehow, do stuff, and then profit at the end depending on how long you've had that box for and how the scoring service works. So if it was checking in for a banner, making sure that it was always your banner so that you would get the points for it, right? Well, the way that we're proposing now is using Ansible playbooks to quickly move whatever it is your secret sauce is to all of these machines, and then using SaltStack for that long-term access to bypass egress filters.
Doing DevOps for your DevOps. Buzzword.
Yeah. So, we're going into about 15 minutes left, and we're going to try to do a live demo for this. We'll have 15 minutes because we're sure this live demo is going to be a live demo, and if you've ever been to them, they usually fail. So, as we set this up, do you guys have any questions that you want to shout out about the DevOps or Ansible and SaltStack stuff in general?
No questions? Do you want to do the watch?
Yeah. Okay, so I should probably zoom in on this before I do this. Cool.
Can everybody see that?
We'll make it a little bigger. All right, cool. All right, so let's go ahead.
So you can see on the top there, that's on the Salt master server. And what that's doing is every time a minion checks in for the first time, it will list its keys that you have to accept in order to be able to start pushing stuff to those boxes.
Yeah. So we're going to go ahead and run this Ansible playbook, which just goes out, uses Ansible to install SaltStack on all these machines, and then we'll call back to us so then we can execute whatever commands we want.
So all it's doing is executing that bootstrap command that was using Python to install the minion.
Yep.
So, like we mentioned before, it's actually pretty quick to run this, but running it across like the 3 hosts, 2 of them are Ubuntu and 1 is CentOS, and so the Red Hat based ones like will check in quicker. That takes about a minute for everything to be configured and installed. So that will show up under the unaccepted keys in a bit. For the Ubuntu ones, it usually takes a little bit more because it runs apt-get update to update all the repos every time the script is started. So that takes like 2 to like 2.5 minutes for those to complete. But once those are completed, the Salt minions themselves, after you accept the keys, have to do some background stuff to like finish configuring themselves. So even though like they check in and you accept their keys, they still might not be, yeah, you can see the first one finished, so that's the CentOS box. It still might take a little bit for the hosts to be configuring, so you can't send commands immediately. It might take an additional minute, and then after that next minute, what you can do is then you can execute all of your state files that you want to send out to all of the hosts. So that would be the stuff that you say, add these users, drop SUID files, install GCC, drop SSH keys, all that good stuff. So
it's important to note too that I mean the word key might get in the way, but all of the communication between the Salt master and the minions is encrypted. So another bonus, so that whatever custom thing that you have written, typically what I've seen in these competitions, they're not encrypted, so if you just do TCP dump, you can see what your competition is running against your machine, and then better prepare yourself to defend against it. Or just take over whatever IRC bot that they have if you go to their IRC server. So this kind of eliminates that from the scenario by just having a salt master that can execute commands over an encrypted tunnel. So, like we said there, we see the 3 changed, so that way we know that salt has successfully been installed on these machines. So, DevOps and pretty hard together right now. We're using Ansible to install Salt Stack. Feeling pretty good about it. Bryan right now is accepting these keys, so that way he can issue out commands. Oh, nice.
Sorry.
So he can issue out commands as master to all the minion servers.
So now you can see that all the keys have been accepted. So what I'm going to do is, if I can spell, sorry.
I'm going to go ahead and hit the mute button.
So what you can do is salt, and then the next thing that you type is what specifies the host that you want to say send information to. So what I'm saying is that every host, I want to basically send a test ping to tell me whether it's alive or not. So that's actually pretty cool that those all worked on the first time. Was not expecting that, so that's cool. Because usually it takes a little bit for those to finish configuring themselves in the background. So now what I'm going to run... Well, what I'm going to run and try to type correctly is applying all the states. So what this is going to do is every time all the hosts check in, it's going to look for the top file, and you can see that RDP was enabled and it's still running. So on the Windows box, it was good to go. So it might take a little bit more. It'll probably take about another minute and a half to add all the users, drop the SUID binaries, drop the SSH keys, and yeah. Does anybody have any questions?
Yeah.
Yeah, I got one. So if you guys run into a scenario where network-based controls prevented SSH from, from every system in an environment, you were restricted to say like a subnet or a VLAN, where you had like proxy around to try and make this work.
So at Pwnage, which is an event that they run at CCDC, which is, so CCDC is primarily a blue team event, except for the last day, they run something called Pwnage, where they allow all the blue teamers to just try to take over an environment and change the flag. So there's always a music box, and everyone goes to the music box to change the music for the entire room. I'm not sure what team got it last year, but they just started playing Game of Thrones music throughout the whole thing, and they were... blocking subnets and stuff like that. So that was one of the things that kind of if we were faster, we would not have this problem and listening to this really daunting music just blasting through the speakers. So that, out of frustration, that kind of sparked it too.
So you can see that it just succeeded for all 3 boxes because green is good, so that's cool to see. So now, here, do you want to try to SSH in 191? Sure. So we dropped Jared's SSH key, so hopefully this works. So he's gonna try Bill. So Bill at that box should have his SSH key, and now we're in. So
Nice.
yeah.
So once again, these salt minions on all these boxes are running as root. So these are as good as root shells, if not better, because it has this nice encrypted command communication and supports all of these really cool salt files. So that way, if you're in an environment, you're like, hey, I suddenly have all these Windows machines, but I need to do something I've never done with Windows. The Salt community itself is pretty active, so you can go grab a state file that could be for a legitimate purpose of configuring some kind of service and totally use it to your advantage. So there's a large community behind this for DevOps and system administration. There's nothing stopping you from taking them, tweaking them, and using them to your competitive advantage, which is really what this is all about.
So we also dropped SUID binaries, compiled one, and threw it in the path, and we called it Watchdog D. So you can see you just run that command and then your root. So even if they disable root login, you can still have root on the box. So
yeah. So all in real time, you saw us do this, 3 machines, a couple of minutes, and this is continued access. So we'd like to open up to any other questions that we have, because this demo worked a lot better than what we planned for. Yeah.
I'll ask another one. So what about cases where egress filters prevent you from pulling down, say, like a Git package
You absolutely can. So one of the problems with comes to the trade-off with the SSH pipelining is that it's reported that when you're transferring like larger packages, so depending on how big what you're trying to get from A to B is, it can take more time. So like at minute 0, if you kick that off and you have all these pre-packaged and ready to go, that by all means will work. It might take a couple extra seconds, but in the long run, that could be advantageous if someone else is just going to start firewalling off subnets and whatever ports it may be. Yeah?
Is there a reason why you guys didn't use Puppet or Chef?
Awesome question. So, Puppet Puppet's really cool and so isn't Chef. The reason that we didn't go with Chef is because the infrastructure overall to set that up and start managing it is a little bit more heavier, whereas with Salt and Ansible, you can kind of walk into a competition and just have a laptop and run this. The Chef server tends to be a little bit bulkier depending on what you're trying to do. But for Puppet, I believe for the non-enterprise edition, there's a limit of how many nodes you can have, if I remember correctly. And also just for Ansible and SaltStack both being in Python and both having that YAML format, it's super easy if you have something that you want in the Ansible playbooks to be converted to long-term stuff for SaltStack. So that is really the bare minimum. There's no reason that you can't use those tools. We just chose to go with these. Yeah.
Also, Ansible being agentless would allow you to configure network elements like firewalls and switches and things like that.
Absolutely. All right, well, I mean, if you guys have any more questions, we just wanted to kick it off. We thought there'd be more, but we'll be hanging around here if you guys have more questions. Thank you very much for coming to our talk.
Yeah,
appreciate it.
Thank you.